Hello and welcome to this lesson on calculating mean absolute deviation. The learning target of the video is finding MAD, which is an acronym for mean absolute deviation. Now first, some of you might be wondering, what's with all the negative words in statistics? We have words like mean, and now we have a phrase, MAD. What's with all the negative words? To be honest, I don't know. I can tell you a lot of people do not like statistics because there is an element of uncertainty. A lot of people grow up and love math because there's a certain answer. There's a right answer and there's a wrong answer. But with statistics, you get into sort of a lot of gray area, and things may be right, things may not be right. There's a percentage of the likelihood of something happening or something like that. And people don't like that. So maybe that's why there's these negative words. I don't know. Anyways, let's first of all take a look at what MAD is. Now, like I said, MAD is an acronym. It stands for mean absolute deviation. And we have to break down what these words mean. Well, mean is an average. And then absolute deviation refers to distance. There we go. And so what MAD is, and it's kind of cool when you think about it like this, it is the average of how far away from average you are. Or another way of saying that is it is the average distance from the average. And so what that means is we're going to take a look at a bunch of data, and we're going to just take the average of how far each data point is from the average. And so it's kind of a meta average. Now, let's think about, where is this relevant? What could this do for us? So let's consider this situation. Let's say there are two companies. You have company A and you have company B. Both companies are popular. Both are doing quite well. And in one company, the average employee earns $80,000 a year, especially for the position you're looking to apply for. And you're like, okay, cool. In company B, the average employee, again, maybe for the position you're looking to apply for, earns $75,000. And so both of these are sort of the average. Now, I ask you, which company do you want to work for? Answer is obvious. You're going to want to go for company A if you're just looking at money. You're going to make a little more money. But let's dig deeper into the details, and let's look at MAD. Let's say, and these are just hypotheticals that help me kind of explain a point here, that at company A, there are 5 employees who have the job you're looking for. One makes $60,000. Another one makes $60,000. Another one makes $60,000. Another one makes $60,000. And then the final one makes $160,000. Whereas at company B, the corresponding 5 employees who have this job all earn $75,000. Which company do you want to work for now? This is where MAD would come into play. MAD is a useful statistic for a situation like this. While the overall average is greater for company A, making $80,000, if you take a look at the data, it's being skewed because this one person is making so much more than everyone else. Whereas here, you have a very low MAD. So here you'll have a low MAD, and over here you have a high MAD. And so perhaps company B would be the better company to work for because right off the bat you're going to make $15,000 more. And then perhaps that goes up, and who knows if there's opportunities to compete and kind of to grow in that role. But the point is just to make a point about looking at what everyone is getting. And so MAD can kind of help us take a second look at the average. Is someone carrying a lot of weight for the average, or is it relatively equally distributed across all the points? And so now let's talk about how we find it. Let's talk about the process. So there's a couple of steps that we need. First step, you have to find the mean. So you can't find the average without finding the mean first. Second, you need to find the distance each point is from the mean. All right. I'm going to highly recommend you use a table. All right. So this is one of these, it's not a complicated thing, but is a tedious thing because you need to write down a lot of numbers and you need to keep them organized so that way you don't cross any of the numbers up. Finally, you find the average or the mean of the distance. And that's it. 3 steps. Nothing terribly complicated, but something that will take some work. So let's take a look at an example. My example is just a set of numbers 1 through 9 excluding 5. So there's no 5 in here. And you'll see why in a second because it's going to help with crunching some numbers. Okay, so let's find the mean. That's the first step. So I have to go 1 plus 2 plus 3 plus 4 plus 6 plus 7 plus 8 plus 9. And then we have 1, 2, 3, 4, 5, 6, 7, 8 data points. So we'll divide that by 8. All right, so if we go 1 plus 9, we'll get 10, 20, 30, 40. So we'll have 40 over 8, and our mean is 5. Now that was step 1. Step 2, we need to find the distance each point is from the mean. And so here's where I want to use a table. So you can do it vertically or horizontally. I'm going to go vertical. I'm going to go horizontal. So I'm going to rewrite every data point. 1, 2, 3, 4, 6, 7, 8, 9. And then underneath it, I'm going to be looking at the distance it is from 5. And so that's the question. How far is this from 5? Well, 1 is 4 units away from 5. Actually, let me do this in a different color here. So 4 units from 5. 3, 2, 1. 1, 2, 3, 4. Oops. So what I want to do is use these numbers and find the average of those numbers. And so let me see here. This will give me 7, 9, 10. And then we have 3, 6, 10 again for 20. So 20 over 8, which is equal to 2.5. And that is our MAD. Again, nothing terribly complicated, but it does require a lot of little number crunching and staying organized. So let's do another example just to kind of walk through it so you can see it again. All right, let's say we're looking at someone's test scores. We have an 88, we have a 90, followed by another 90, followed by an 86, followed by an 84. Step 1, you have to find the mean. And so that's 88 plus 90 plus 90 plus 86 plus 84. All that's going to be divided by 5. And so when we crunch those numbers, which I'm using a calculator for, we'll get 438 divided by 5. And when we actually divide by 5, that gives us 87.6. Now, this is where it's going to get a little more complicated, but it's something we can handle. So what I'm going to do is I'm going to kick up my table another notch just to kind of help show you the process I'm using. So I'll rewrite all those numbers. 88, 90, 90, 86, 84. Now where I'm going to kick it up a notch is I'm going to add another row right down here where I'm going to show you the math I'm doing. So here I'm going to go 88, different color, 88 minus 87.6. 90 minus 87.6. 90 minus 87.6 again. Now watch the switch I do here. 86 is smaller than 87.6, so I'm going to go 87.6 minus 86. And then same thing, 87.6 minus 84. And so when I crunch those numbers, my distance for each one of these data points is the following. These numbers right down here. 0.4, 2.4, 2.4, 1.6, and 3.6. Then the final step is to find the average of these. So add them all up. 0.4 plus 2.4 plus 2.4 plus 1.6 plus 3.6. All of that divided by 5. Crunch the numbers, and you get 10.4 over 5, which is 2.08. And there we go. And so that, again, represents our MAD. So to wrap everything up, MAD is the average distance from average. It's nothing terribly complicated, but it does require a lot of tedious number crunching. And again, I recommend that you use a table. So you have all your data points, you put them at the top, whatever they are, 1, 2, 3, 4, 5, and then you find out what the difference is from the mean, and then you find the average of those numbers. It'll just help you crunch them so much faster. If you have any questions, please let me know.